our mission today is to break down, why a seemingly clean vent doesn't actually guarantee a working vent. That you actually need to prove that a hidden system is truly doing its job.
If we can't physically observe the entire system in action, we have to demand tangible, measurable proof that it works.
Tangible data.
Right. We have to take that invisible movement of air, all that invisible friction inside those walls, and basically translate all of it into hard, undeniable data.
Yeah, it's so tempting to pull the dryer out from the wall to make room for them before they even knock on the door. I do that all the time.
I know, everyone does. But doing that completely sabotages the whole diagnostic process. The exterior termination, which is the vent cover on the outside of your house, that cannot be adjusted either.
Wait, what if there's an incredibly obvious blockage? Let's say that flexible hose is just severely crushed against the wall, or the outside louver is totally stuck.
They have to leave all of it entirely alone for their very first measurement.
Man, that is so hard to do.
The technician's entire goal in those first 5 minutes is to capture the precise physical conditions that prompted your service call in the first place. Think about the mechanics of troubleshooting. If a technician walks in, grabs the dryer, and pulls it forward, and in doing so, they unkink a severely crushed transition duct. Well, that original airflow condition is gone.
Oh, wow.
It vanished the second they moved the machine.
And they haven't even turned their meters on yet.
Exactly. Or, if they walk outside and brush a heavy layer of lint off the exterior vent cover just to see inside, they've fundamentally changed the physics of the system. They can no longer answer the most fundamental question of the entire visit.
Which is what?
Which is, how is this complete dryer exhaust system performing right now in the exact state that has been causing the customer grief?
I see. So you just lose the before completely.
Completely.
And without a before, any after measurement you take later on has literally zero context?
Zero. It's just a random number.
How do we actually take this sacred measurement? I mean, we're talking about a system that is completely hidden behind drywall. And the thing we're trying to measure, exhaust air, is invisible.
Right, and this is where the industry relies on highly specialized diagnostic tools. You have to translate invisible physics into visible numbers.
Okay. I mean, why can't the technician just turn the dryer on, walk outside, put their hand over the exterior vent, and feel if the air is blowing hard?
See, that is the exact trap the document warns against. The hand test is entirely subjective.
What do you mean?
You literally cannot feel static pressure with your palm.
Wow, okay, fair enough.
Let's break down methods the document outlines so you can see why specific data is so necessary. The first one is anemometer testing.
An anemometer. Okay, I've actually seen these. It's a handheld device with a little propeller or fan on top, right?
Yep, exactly.
And it measures the velocity, like the actual speed of the air. And you typically use this right at the exterior vent on the outside of the house.
Correct. The anemometer tells you what air actually survived the journey.
Survived the journey?
Yeah, think about it. By the time that exhaust reaches that little spinning fan outside your house, it has traveled out of the dryer drum, squeezed through the flexible hose, entered the wall cavity, slammed around every elbow, fought its way up any vertical climb.
Just a brutal obstacle course.
And pushed past the termination point. So the anemometer measures the final velocity of whatever air made it through all of those obstacles.
Got it.
And that brings us to the second method, which is back pressure testing. Measures the resistance at the very beginning of the line.
Wait, how does that actually work physically? How do you measure resistance in a pipe without blocking the pipe yourself?
Good question. The technician will typically create a tiny sealable test hole right at the beginning of the ductwork, right behind the dryer.
Oh.
And they insert a specialized static pressure probe that's connected to the digital manometer. So as the dryer blows air into the duct, the manometer measures static pressure.
Static pressure.
Yeah, think of static pressure as the force the air is exerting outward against the walls of the pipe rather than the forward movement of the air. If the hidden duct inside your wall is perfectly clear and relatively short, the air flows easily. The outward pressure is low, and the back pressure reading on the manometer stays low.
Makes sense.
But if that duct is heavily clogged with lint, or, say, it has too many sharp turns, the air gets backed up. It hits those blockages and pushes back.
Wow, which gives you such a drastically different perspective on the system. The anemometer outside is asking how much air is arriving, while the manometer inside is asking how much resistance is the machine fighting.
Spot on. Both give you pieces of the puzzle.
I see why you need both now.
Yeah.
And then there's the third method they mentioned, which is dryer drum vacuum testing.
Right. This one measures negative pressure directly inside the operating dryer drum itself.
Inside the drum.
Yes. The vacuum test measures how hard the dryer is struggling to inhale and process the air within its own drum.
Okay, so synthesizing all of this, it completely dismantles the idea that air is air, or that you can just put your hand over a vent and call it a day. An anemometer measures what arrives at the end, a manometer measures the struggle at the beginning, and a vacuum test measures the core environment inside the machine.
Right. And the text emphasizes that it almost doesn't matter which of these three specific tools a technician prefers to use.
Really?
Yeah, as long as they are adhering to the foundational principle, which is measure performance rather than assume it, you are converting an invisible physical process into a consistent data point.
Right.
You need a controlled scientific baseline, otherwise your numbers are just random noise.
Which introduces this totally fascinating operational rule about how these tests have to be run.
Ah, yeah.
Because once the technician has their tools hooked up, if they want to eventually compare this before reading to an after reading later on, the conditions of the machine must be absolutely identical.
Absolutely identical.
The dryer drum has to be totally empty of clothes, the lint screen has to be scraped perfectly clean, and crucially, the machine has to be operated on air only, with no heat. That feels completely counterproductive. I mean, the entire purpose of a clothes dryer is to use heat to evaporate moisture.
It seems bizarre on the surface, I know, until you dive into the physics of thermal expansion.
Thermal expansion.
Yeah. By mandating that the machine run on air only, you completely remove thermal expansion from the equation. You isolate the physical mechanism of the airflow itself.
That makes so much sense.
You create a perfectly controlled, mathematically consistent environment. Phase 1 complete.
Now, finally, they get to do the physical work. They run their inspection cameras through the walls, they diagnose the blockage, they use their rotary brushes to sweep out all the lint, they unkink those crushed hoses behind the dryer. The visual part of the job is done.
Right.
But the most critical moment of this entire protocol, the absolute core argument of this document, is what has to happen next.
Closing the diagnostic loop.
Yes. The Dryer Vent Safety Council promotes a very specific 5-step sequence for this. It goes measure, inspect, diagnose, service, and then measure again.
That second measurement is where the truth comes out.
Yeah, there's a quote in the text from Terry Rohr, the co-founder of the council, and she crystallizes the entire philosophy perfectly. She says, the before reading tells you where the system started. The after reading tells you what the service actually accomplished. Without both, how do you really know?
The scientific methodology proves its worth, and where visual inspection fails.
How so?
Well, if a technician relies solely on what they can see, they look down the pipe with their camera, they see clean metal, they assume success, and they leave the house.
Ignorance is bliss.
But if they are strictly bound by measurement, a terrible after reading forces a hard stop. It forces them to look at the data. A clean pipe doesn't mean a functioning pipe if the pipe itself is built incorrectly.
Right.
The text points out several common structural failures that measurements uncover. One of the biggest is excessive effective length.
Effective lengths.
Yeah. Building codes dictate how long a dryer vent can safely be, but people often forget to calculate the friction caused by turns.
Right. The document mentions 90-degree elbows.
Every single time air hits a sharp 90-degree elbow inside a wall, it slams into the metal, creates turbulence, and loses immense forward momentum.
Makes sense.
In terms of airflow resistance, adding a single 90-degree elbow to a system is the mathematical equivalent of adding roughly 5 straight feet of ductwork.
Wait, 5 extra feet of resistance for every sharp turn?
Yes. So you might have a vent that physically looks like it only travels 15 feet through your house. But if the builder snaked it around 4 sharp corners to get outside,
Oh boy.
that duct mathematically acts like a 35-foot tunnel.
So what happens?
The lint slows down, drops out of the airstream, and clogs the system.
And no amount of rotary brushing is going to fix the fact that there are too many elbows in the wall.
Exactly.
Or maybe the duct was permanently crushed by a careless contractor inside a ceiling cavity where no camera can reach. Or, the builder installed an incredibly restrictive vent cover on the outside of the house that basically chokes the air right at the finish line.
This just highlights the vital distinction the text makes between inspection and measurement. Inspection, using your eyes, using cameras and flashlights, that tells you why a system looks the way it does.
Right.
But measurement tells you how the system is actually performing under pressure. They are two halves of a complete diagnostic picture.
You need both.
You really do. If a technician only inspects, they miss the invisible pressure problems.
Which brings us to the ultimate question for you, the property owner, sitting at home listening to this. What does all of this rigorous, almost obsessive data collection actually mean for you?
Yeah, why does it matter?
Exactly. Why should you care about static pressure probes and effective duct lengths?
Because it represents a fundamental shift away from an industry built on blind trust toward an industry built on evidence.
That's the key right there.
It is. For decades, the entire relationship between homeowners and service professionals regarding hidden systems has been based on taking someone's word for it.
We cleaned your vent. Here is the lint. Trust us.
Exactly. But you cannot watch air travel through concealed ductwork. You cannot see the turbulence inside a wall cavity. Measurement Act, a technician utilizing this methodology isn't just saying they did the manual labor. They are mathematically proving that the physics of your home have improved. It forces accountability on the technician, and it empowers the homeowner with reality. The core message of the document takes a classic business management maxim and perfectly applies it to the safety of our built environment. What's not measured cannot be managed.